Hi, this is George Graybill again, reading another chapter from the book Stuff, the fortunes, foibles, and fiascos of those who sought to understand matter. This is chapter 9, the birth of the periodic table, or Dmitri's dream. As Democritus and some of the other old-timers pointed out, everything is always changing. Some things change very slowly, like continental drift. Other things change rapidly, like lightning zaps. What's the point? Why can't stuff just give us a break and settle down for a while? You may remember that we saw that looking for the purpose for change is pretty pointless. It is better to ask how and why things change. Keep in mind that there are two kinds of change. Changing stuff into another form of the same stuff and changing stuff into a new kind of stuff. For the first kind of change, stuff can usually be persuaded to go back to the way it was. Melting and freezing water is an example. For the second kind of change, often the change can't be reversed. For example, you can't unrot a rotten apple. You can recycle a bent can, but you can't recycle exploded fireworks. Chemical changes are just one example of the problem of things tending to go downhill or become less useful. This problem is stated by the first two laws of thermodynamics, that is, changes that involve heat. The first law, you can't get something for nothing. The second law, you can't even break even. The third law is only slightly less depressing. No matter how cold it gets, you can count on it never getting below minus 460 degrees Fahrenheit. We're not making these laws up, we're just stating them very simply. Another problem is making sense of all the many chemical changes. So it's the middle of the 1800s, and what do we know? The alchemists, even with all their wizardry and superstitions, found out some things about elements. People knew that there were a small number of these elements, elemental kinds of stuff, and that were basic and couldn't be broken down into more kinds of stuff. Science had also pretty much given up on the old fire, air, water, earth list of elements. It was also known that elements could combine into more complicated kinds of stuff, called compounds. The fact that elements always combined in the same ratios led logically to the comeback from the atom idea, the comeback of the atom idea, after 2,000 years in the trash can. We also saw that the atom idea can be used to explain some things about stuff like pressure and temperature. One of the big puzzles in the 1800s was trying to make sense of the patterns in which elements combined. The goal was to put all the information from all the known chemical reactions into one grand scheme. This was a real headache, and the first tries at seeing the big picture were pretty much just a mess. The first scientist to come up with a consistent pattern was the Russian Dmitri Mendeleev. Here's a picture of Dmitri. Dmitri looked like a mad scientist in a science fiction movie. He wasn't mad, just unlucky. His arrangement of the elements was called the periodic table, and it is amazingly like the one hanging on the walls of chemistry classrooms everywhere. His method was to list the elements in order of atomic mass. Atomic masses can be figured out experimentally from combining ratios without really having any idea what atoms are or what they weigh. You don't even have to believe in atoms. He listed the elements in rows. When properties repeated, he started a new row. This caused the elements to become grouped vertically in families that had similar properties. There's an old story that the idea came to Mendeleev in a dream. He never said that publicly, but someone said that someone told him that he heard that Dmitri had said it. Since the story probably isn't true anyway, we may as well make it even more interesting. This is called perpetrating a hoax, which is irresponsible and a lot of fun. One night, Dmitri was playing checkers with his friend Ivan the Terrible. Dmitri was winning every game because Ivan was a terrible checker player. That's how he got his name. About midnight, Dmitri got so bored he said, "That's enough for me, Ivan. I'm going to bed." That night, in a dream, Dmitri realized that the real reason he was bored with checkers was the checkerboard design. It was just blank red and black squares. He thought it would be a lot more interesting if the squares had some information on them. Since he was a chemist, he started writing symbols of chemical elements in the squares. Now this, he thought, in his dream, had possibilities for a very interesting game. I should note that the term atomic weight has been replaced by atomic mass. If you really want to know the difference between weight and mass, take another look back at chapters 4 and 5. And when he woke up, he remembered the dream and started writing down chemical symbols on his checkerboard in order of atomic weight. Working from lightest atoms to heaviest atoms. When he had finished a few rows, a light bulb suddenly appeared over his head and he shouted, "Holy borscht, look at that!" He had realized that elements in the same column had the same properties. He got so excited about this pattern of repeating properties that he forgot all about creating a game. He called his discovery the periodic law, which made him so famous he became a household word that no one can spell. Here is Mendeleev's original periodic table on the left. It's hard to read because the periods are vertical instead of horizontal. On the right is the same information rearranged the way we like to see it. Strangely enough, Mendeleev never believed in atoms. Even if he had, there were still too many missing pieces for him to have fully understood the importance of what he had created. Dmitri's discovery was brilliant in that he was able to see a pattern hidden in a mind-boggling amount of data. But was it chemistry? For that matter, was it science? It was definitely science because the periodic law could be used to make predictions, which is one test of a valid theory. You could actually use the periodic table to predict the formulas of compounds that had never been prepared. What was missing was the underlying reason for the pattern of chemical properties. It was as if Mendeleev had solved a Sudoku puzzle, leaned back and said, "What's the point? I just wasted an hour of my life." It was not until many years later that the pattern was explained. Mendeleev's table was actually a diagram of the internal workings of atoms. That's the end of chapter 9. Chapter 10 is also about Mendeleev, and it's called Defense of the Periodic Table, or Mendeleev's Press Conference. So I'll be doing that before too long. If you scroll down, you'll see a link to a place where you can buy the book, look inside the book a little bit, and read reviews and so forth. And if you want to subscribe to my YouTube channel, there should be a subscribe button somewhere down in the lower right-hand corner. Thank you. That's all for now. See you again. Bye.